Hi, and welcome back to the Business Career College video series. In this video, we're going to have a look at the Rule of 72. The Rule of 72 is sort of a quick math way of doing potentially more complicated calculations involving compound interest. So we're going to start just with a quick example of how the Rule of 72 works. So what we do is we take an interest rate and we divide it into 72. So let's say that we have our 72 here, and let's say that we have an 8% interest rate. So we have an investment that's earning 8%. And if we just take 72 divided by 8, just like so, that gives us 9. And what that tells me is that it will take 9 years for an amount that's invested at 8% to double. So I have a 9-year doubling period, which is useful, of course, if you're investing at 8%. And you'll see that you can do the same thing with all kinds of different numbers here. Lots of numbers divide evenly into 72. So if you have 3 or 4 or 6 or 8 or 9, those all divide evenly into 72, 12 as well for that matter. And even if not, if you have, let's say, 5, so 72 divided by 5, well, that doesn't work out perfectly, but it's pretty close. It's just a shot over 14. So here I would have a 14-year doubling period. And since really this is just used for approximation, that's just fine. There's no reason why I would do things any differently. Or if I had 72 divided by 10, I would have a 7-year doubling period. So let's say then that we did, and we'll just work through a little example here. Let's say we invested $1,000 and we're earning 8%. So I can see that after the first 9 years, because remember we're working with a 9-year doubling period, I would have $2,000. That's after 9 years. And then if we keep going and we double again, assuming we're still getting that same 8%, after 18 years, I would have $4,000. And then if you keep going and you double again, we would have, after 27 years, we would have $8,000. And how about one more here? After another 9 years, for a total of 36 years, you would have $16,000. So fairly straightforward, really, with this type of application of the Rule of 72. Now, this has all kinds of other applications, isn't it? And as you get used to it, it becomes quite useful. So let's say, for example, that inflation is 3%. We project inflation out to be 3%, and I don't want to get too much into inflation assumptions. We'll deal with that elsewhere. But we have inflation projected at 3%. And we have somebody who goes to work today, and that person is making $50,000 per year. And we say, okay, what's the salary going to be if only inflation changes? No performance adjustments or no promotions or anything like that. If only inflation causes this salary to change, what would that translate into in 30 years? Pick whatever time frame you like. It doesn't really matter. So we can take 72 divided by 3. So again, what's my doubling period going to be here? And 72 divided by 3 does divide evenly, so that's 24 years. So we know that this person's salary is going to double, going to go from $50,000, and that in 24 years, it'll now be $100,000. Now, there's a little bit left over here. There's 6 years that we didn't use. So I could say, well, it's not going to quite double then. I could do a little math here. I could do 6 divided by 24. That's 1/4, or 25%. I could say, hey, it's not going to double. It's going to get 1/4 of the way to doubling. So if it's going to get 1/4 of the way to doubling, I can just add 25% here, and it would work out to about $125,000. If you actually work through it in a financial calculator, you'll get an answer right over just over $121,000. So this is a pretty good approximation. Bit of quick and dirty mental math here. So now, one more exercise. Let's say that we have somebody who's investing. And this person has a target of $1 million. That is, at some time, let's say 25 years from now, this person wants to have $1 million, and they currently have $100,000 invested. And they say, what rate of return do I need to get this $1 million in 25 years? So how do we do this? Well, we say you've got $100,000 here, and we want to double that. So we're going to get to $200,000, and we want to double it again, and we're going to get to $400,000, and we're going to double it again, and we're going to get to $800,000. So we'll just make a little room on the screen here, and we see that now we're not going to get to, if we do another doubling period, we're too far. So instead, I can see that 800,000 times 1.25 times 1 1/4 is going to give me $1 million. So in total, we've doubled 1, 2, 3 1/4 times. We've got 3.25 doubling periods over 25 years. So approximately, I can see then, I can actually math this out, that we have to double every 7.7 years. Let's call it 8, since we're just approximating anyways, so we'll say that's 8 years. So I know I have to double every 8 years. So now I'd say, okay, 72 divided by what gives me 8 years. I can just pull a little cross multiplication here, and I can see then that 72 divided by 8 is going to give me my x here, or 9 is my answer. So I've got a 9% return is what it's going to take me to get from $100,000 to $1 million in 25 years. If you were to actually do the longhand math, you would see that the answer would actually be 9.64%. Again, pretty close for just a quick approximation, and the kind of thing that you could comfortably do on a napkin or whatever you happen to have. So this is the rule of 72. These are some of the applications of the rule of 72. There are lots and lots of potential applications of it, and the ability to do this kind of quick mental math will help you to first off confirm that you're doing math that you do in your calculator more quickly, and it'll just get you comfortable with working with compound interest calculations. So I hope that helps. Lots of applications of rule of 72. It does show up on the LLQP exams, and for those of you going through other programs, it's just a useful way to double check your own math. So I hope that helps, and enjoy your continued studies. Thank you.